presentation is Google Cloud Threat Detection, a study in Google Cloud by Dave Johnson, and it's sponsored by Prowler Pro. Prowler Pro was developed with security practitioners in mind by the team who created Prowler, the top open source AWS security tool. Prowler Pro is the ultimate CSPM solution for AWS, aiding security audits, compliance, incident response, and infrastructure hardening in minutes. Stop by their booth for exclusive swag. So over to you, Dave.
Thank you very much. Hello, everyone. Thank you so much for coming to my talk. Today, I will be sharing some research we've been working on at Datadog in regards to Google Cloud Threat Detection. I was actually supposed to do this talk with a coworker of mine, Martin. So, Martin, if you're watching this, I hope I do your research as well justice in this talk. All right, so a real brief intro about myself. My name is Abisola Dayspring Johnson. By go by day, I am a security engineer at Datadog, where I focus on research and detection engineering for multi-cloud environments as well as SaaS integrations. Some fun facts about myself: I am 21 years young. It's my first time in California, first time at Forward CloudSec, and also my first in-person talk. Thank you. All right, so this is a basic outline of what I will be going over in this talk. And my goal is that I leave you with actionable insights on how to use known as well as lesser known threat activity to guide your efforts in development of Google Cloud Threat Detection content. So in our research for various Google Cloud threat detections, we incorporated community-derived research and threat hunting methodologies into our process for developing these various detections for Google Cloud. And when we modeled these detections, we modeled them into two different categories. The very first one being knowns. So these are techniques that have been observed in the wild, so from various threat actors, campaigns, or malware. And the second the second category we model these detections to were unknown. So these are things that are likely to have been used in the wild. So basically our research from various red team engagements or security research and pen testing methodologies. So by covering detections from both of these different categories, we're able to have a really good coverage for detections for our Google Cloud environments. Now this is a sample attack path that we'll be going over in this talk. Obviously, there are various possible permutations or even levels of visibility based on permission boundaries and different access levels in your Google Cloud environment. But this is a potential attack path an attacker might try to take with different resources within your Google Cloud environments. So let's get started with what we actually know. The very first detection we'll take a look at would be detecting when a default service account is being used outside of Google Cloud. Now, this is a typical initial access vector due to compromised default service account keys. And just like other keys in other cloud environments, this is typically how attackers gain access into a Google Cloud environment. Now, the thing about this is service accounts are typically used by resources or applications rather than users. And currently, Google Cloud has two default service accounts. The very first one being the App Engine service account, and the other one being the Compute Engine service account. Now, when a default service account is being used outside of Google Cloud's IP address range, this could suggest potential compromise of the service account because we typically expect the service account activity to occur from within Google Cloud environments. Now, the other issue with this is the fact that Google Cloud service accounts, the default service accounts, are highly permissive by nature. Now, the default service account comes with almost 7,000 permissions that give them access to various resources at the project level, and it makes it highly permissive. So whether it's the App Engine default service account or the Compute Engine service account, you can expect that these service accounts come naturally with a lot of permissions. So how do we actually approach detecting this? Now, bear in mind that the queries that I'll be using throughout the rest of this talk are Google Cloud Log Explorer queries, but you can easily translate these to any detection queries that you use for any sort of tool for your detections in your environment. So basically, we're looking for any API calls that are coming from these default service accounts, and also looking for when these activities are not coming from the Google Compute Engine user agent or App Engine user agent, because this is where we typically expect that these service accounts are used from. Now, of course, with this sort of query, it's bound to generate a good amount of false positives based on how your environment is configured. So you can go further by excluding private IP address ranges and Google Cloud IP address ranges to reduce the false positive ratio. Now, if service account keys are not being created in the first place, then they can actually get compromised. So another way to avoid this is by completely avoiding the use of service account keys and using more short-lived credentials like tokens for access to these service accounts. And then finally, you can add some context by enriching these detections with various things such as if the activity is coming from specific IP addresses or VPNs or anonymized services such as Tor or ASNs that are not familiar with your environment. Another thing you can look out for is for when these service accounts are specifically being used from other cloud environments such as AWS, Azure, and other cloud environments. Now, the next detection we'll be taking a look at is detecting when the service account key creation which sort of builds on the previous detection of malicious service account usage from outside of Google Cloud environments. Now, service account key creation basically allows an attacker to maintain access persistence within a Google Cloud environment. Now, this particular tactic has been recorded in several various incidents, including ones by Palo Alto's Unit 42, as well as Expel. The thing about this is each service account is associated with a public and private RSA key pair, and the actual service account keys are the private key pair that belongs to the service account. Now, the problem with this is the fact that the service account is mostly immortal by nature because these keys almost never expire. Now, by immortal, I mean that these service accounts outlive all of us. So when you create a service account key by default, it persists till December 31st, 9,999. So I had to Google this to see how long from now this is, and it's about 8,000 years from now. I don't think any of us is going to live that long, and if you are, we should probably talk after this. Now, you can limit this risk by, you can limit the risks of these default service accounts that are immortal by not creating them in the first place and using, rather than using keys, you can use short-lived credentials like OAuth tokens or OIDC tokens. Or you can also limit the lifetime of the service account keys. So initially, Google didn't have a feature for limiting the lifetime of service account keys, so they could basically persist for about 8,000 years. Now, you have the ability to limit the lifetime of these service account keys to a couple of hours so that you're not having these keys persist for way too long within your Google Cloud environment if they eventually get compromised. So how do we actually approach detecting this? We're basically searching our logs for when the create service account key API call is made within the Google Cloud environment. Now, you should also note the use of regex for the version here, and we're basically accounting for any version changes or additions for this particular API call within Google Cloud. Now, of course, this is bound to also capture a ton of benign activity, including legitimate key creation, and this is why we look to add context and indicators to improve the confidence of the alert if we see a high level of false positives. But in this case, you have to weigh the risks between false positives and false negatives and basically understanding what normal looks like in your cloud environment. Again, if you avoid the usage of service account keys, then you have a higher confidence when you actually see service account key creation within your cloud environments. Finally, we can also look to various enrichments such as IP address enrichments or unfamiliar ASNs. Also, if you see a change such as a key creation being done to a service account in an environment that is deemed to be dormant, then this is definitely something you might want to take a look at. And a dormant service account in your cloud environment could vary based off of what dormant means in your environment. So, for example, a service account that hasn't been touched or hasn't made any API calls within 30 days could be considered dormant in your environment, but that also is based on how different service accounts interact within your environment. So if you see an activity such as the service account key creation or any other activity coming from this service account in your environment, this might be something you might want to take a look at if it's considered a dormant service account in your environment. The next detection we're taking a look at is the egress firewall rule creation. Now, this is pretty ubiquitous across all cloud providers, where an attacker opens up an egress firewall rule to facilitate crypto mining or other malicious activities. Now, in Google Cloud, this typically occurs after a compute engine instance has been created, but there are also several cases was observed when this happens before the compute engine instance is created. Attackers also use similar tactics with the compute engine network, and the way we actually detect this is by looking for when the compute firewall insert API call is being made with the egress direction and when the destination IP address is all IPs. Now, once again, this is pretty ubiquitous across all cloud environments, so this is probably something that most people are familiar with. And again, here we're accounting for any API modifications or additions that might occur with the firewall's insert API call. Once again, this will definitely capture benign activity. So we always want to add some sort of context to this, but also weigh the risks of false positives and false negatives, and understanding of how firewall creation rules occur within our environments. Also, this applies for the compute engine network creation API call. You can apply this same sort of context for detecting that activity. And once again, we can add some more context with IP addresses or unfamiliar ASNs, but something to look out for here is sometimes attackers try to create default firewall rules within your cloud environments in order to blend in with what looks normal in your cloud environments. So we've observed attackers creating firewall rules with like the name default in them or some sort of iteration of that. So if you observe firewall rules, compute engine firewall rules being created in environments that have the default name or don't fit the conventional naming, the naming convention of resources in your cloud environment, then this is a higher, you have higher confidence that this is something that is potentially malicious in a Google Cloud environment. Now we've gone over the knowns. The unknowns will highlight various techniques that are likely to have been used in the wild. The next thing we'll be looking at detecting would be when an external principal is added as a project owner within Google Cloud. Now, this technique was first recorded by Brad Richardson and Madhav Bhatt in a talk at B-Side San Francisco in 2022. And the way this works is a Google account represents a developer, an administrator, or any identity that can interact with Google Cloud's API. So by adding an external principal or an external user, an attacker can persist within the victim's environment. So in this case, if an attacker is adding an external principal with a Gmail account with the owner permissions, they're basically able to both maintain persistence and in some cases have higher privileges with the owner permissions in Google Cloud. So in this case, for example, we have a Gmail address, but it could be any email address that is associated with a Google account. So this could mean other domains as long as they're registered with Google. So in this account, an attacker is inviting a specific email address to have the owner role within the Google Cloud environment. So how do we actually approach detecting this? Well, an easy way of approaching this is for looking for when a Gmail or Google Mail address is being invited using the insert project ownership invite API call. Now, this is an API call that should be pretty rare within your environment because I don't expect that you are inviting multiple owners with Gmail accounts into your Google Cloud environment all the time. So this is definitely something that is not bound to happen as often as other things within the Google Cloud environment. Another thing would also be looking for when external domains from your organization's domains are being invited using this particular API call within your cloud environment. And that would mean just manipulating this query to fit any other queries that are not supposed to be invited into your cloud environment. Now, once again, with suppressions here and given the alert a higher fidelity, you also want to rate the risks of false negatives and false positives. So for example, although adding a user with your organization's domain might seem normal, it could also be an attacker adding an existing entity into your environment as an owner if they previously didn't have those owner privileges within your cloud environments. So once again, it's all about weighing the risks of what is normal and what is not normal within your environment, and then building your detections based off of that. And then finally, once again, you can look for various indicators such as IP addresses, unfamiliar ASNs, and also specifically domains that are outside of your organization's domain. Now, the very next detection we're taking a look at is detecting when an external principal is modifying or adding, the next detection we're taking a look at is the modification or addition of SSH keys within the GC project metadata. So basically how this works is that an attacker can add or modify SSH keys within the compute project metadata, and this essentially facilitates persistence or lateral movement across various Google Cloud Engine instances. And we can detect this by looking at the set common instance metadata API call for when the modified attribute is the SSH keys. And these things exist in either of the last two attributes within Google Cloud. Now, once again here, you can expect a decent amount of false positives. You want to weigh what that looks like within your environment. However, if SSH keys do not exist, then they can be modified. So a way to avoid this is by using Google Cloud's native OS login, and it's basically a key value pair that you use to allow IAM roles rather than SSH keys. So basically, what OS login does is it simplifies SSH access management to GCE instances by allowing access to them using IAM roles rather than SSH keys. So basically, you just specify the key value pair of enable OS login true within the project metadata, and any user that has the specified and required roles for SSH access to Google Cloud environment will be able to access these GCE instances without using SSH keys. And these are the various roles, required roles. So basically, the most basic one is the compute OS login role, and it's the most basic one. And if the user requires admin access, then the compute OS admin login one would be more appropriate for this. So finally, with this, in terms of enrichments and adding more context, you're probably looking for specific IP indicators or unfamiliar ASNs. And then the final attack we'll be taking a look at is detecting data exfiltration using the BigQuery table export function within Google Cloud. So BigQuery gives you the ability to export table results to various destinations of your choice, and you can probably see where I'm going with this. So if an attacker has console or CLI access, they can exfiltrate data using this function to either a Google Cloud Storage bucket, an S3 bucket, or even Azure Blob Storage. So how do we actually approach detecting this? In this query, we'll be looking for the export API call, and when the destination URI contains any of the prefixes that signal storage for any of the 3 major cloud providers. Now, once again, we'll want to make sure that this is within the context of our Google Cloud environment. So again, there's also a very high chance of false positives. So you also want to look at what does expected table exports look like in your environment. So in this case, with enrichments, then you can add context in the sense that if you typically expect that Google Cloud, these tables are being exported to Google Cloud Storage buckets, and if they're being exported to other buckets rather than Google Cloud Storage buckets, then that gives you a higher confidence in the fidelity of this alert, because you typically expect them to be exported to storage buckets within Google Cloud rather than AWS or Azure. So having context such as that can help you have a higher confidence in the alert when it eventually comes. So bringing it all together, context helps a lot when you're building out these detections. So the more context that you can give to a detection, the higher the confidence you can have in it. And then secondly, secure configuration also helps you have a higher confidence in your detections, because if you have specific things in place within your cloud environments, things that you expect should not happen, when they actually happen, then that gives you a higher confidence in the fact that this might be a potentially malicious activity happening within your Google Cloud environment. Now, these are the various sources that I've referenced in the talk, and they'll be linked in the GitHub repo that you'll be able to access in the next slide. And if you'd like to find out more on other things that I'm working on, you can check out my YouTube channel at DayCyberWalks. I also create cloud DFIR challenges in my free time on various cybersecurity training platforms. So if you want to check that out, you can also scan the QR code there. I also manage a online cybersecurity community, so if you're interested in mentoring or helping out new cybersecurity professionals, feel free to join. All the links will be in the QR code there, and if you're interested in following me, then those are my social media links. So once again, this was supposed to be work that I did with Martin. It was supposed to be 40 minutes, but I hope I was able to do justice to Martin's research as well as my research in the amount of time I was able to do it. And thank you guys so much for listening to my talk. It's been a pleasure.
Thank you, Day. All right, questions for Day. All right, I have a question for you. So what's the guidance that you would give in terms of how narrow you should define detections?
So we typically recommend that you start as wide as possible to understand like what normal looks in your environment, and then start narrowing down from there in order to like increase the level of fidelity or confidence you have in it. So rather than starting really narrow with like a lot of very specific parameters, rather cast a wider net, understand what all of that data looks like, and then slowly narrow down from there.
Yeah, I think that makes sense. In terms of the Log Explorer queries, is it pretty easy to take those and build alerts in GCP from those, or is there some special magic that we would have to do?
Well, you can basically just throw these into Google Cloud's Log Explorer, do these searches, and then translate them to whatever the data looks like with your own, whether you're using Splunk or any other tool. Just look for those specific parameters within the log data within your log aggregation or SIM tool.
Questions? Right.
Hey man, just a quick question. In terms of, great talk by the way.
Thank you.
In terms of the research that you did, was there anything common and you found that, how in AWS space people talk about, hey, look out for S3 bucket. In this, did you find that there was a lot more of, I don't know, maybe data leakage or anything else that you found in the research that you did?
So I guess the most common one we're able to find were the ones with like the firewall rule creation. So this is like it typically always happens with like crypto mining. Then I guess other ones will be like the usage of a default service account outside of Google Cloud. Like that is typically mostly always an indicator if you have the right context with it. But those are the two most common ones that I can point to.
Awesome. And is there anything from Google, as in like a equivalent that they provide themselves, like like a Chromium or whatever they have? Like, what I'm trying to say is there a cloud native solution from Google Cloud for this to be detected? So
yeah, so I believe Google has various detections with their security command center for this. So that could be a first step of detecting these different things.
Awesome, thank you.
You're welcome.
So a lot of your talk went on noise reduction, and cloud environments, they tend to live and to change. And so I was wondering, do you have like a mechanism or an approach to automate all of these noise reduction capabilities?
Well, the best way I can recommend is by adding more context, and that could also be part of your automation. So adding IP enrichment, or even like giving users the ability to verify an alert. So for example, if you observe something such as the table export from BigQuery, you might send like a Slack message to a user, ask them, is this coming from them? That's part of your automation. And if they respond, I did this, then maybe reduce the severity of the alert, move it to a different queue. Or if it's like, oh, I didn't do this, then increase the severity and speed up investigation in that. So you can approach that by either IP enrichment, other various sort of enrichments, also adding context about the user's role. Should they actually be able to do this, and other things like that.
Again, excellent talk. I love the range of different examples you brought to bear in a very short time. Well done.
Thank you.
One of them was a small one, which is adding someone from outside your domain to your project. My question is in the form of, how many different ways do you know of to spell Gmail? right? So there's gmail.com and googlemail.com, but there's a larger category of self and non-self rejection. But the thing is that companies will not just have the one domain they operate in. There'll be a domain for their user content and a domain for that startup they just acquired, and then maybe a domain from a place where their contractor's going in from. Have you had any tips, techniques, or horror stories about realizing, when does a domain name look suspicious and it isn't, or what does a domain name, maintain as a piece of context that you wish you could use in all kinds of rules? Because I've got to say, I've yet to walk into an environment where someone could give you a domains.txt file that says, here are the 113 different ways we spell our company.
Yeah, I don't have much context into that. I would say like the best way I could recommend like just keeping track of that would probably be using like reference tables. So making sure you're keeping that updated so that you don't have to like continuously manually update the rule. So if you have that reference table where you're hopefully continuously maintaining it with the list of like good or known good domains, that should probably help with that. I hope that answered your question.
I look forward to this nirvana in which I can actually check out that table from a Git control repo. Thank you. That was an amazing inspiration.
Yeah, that would be in a perfect world.
Yeah. And to piggyback on his question, do you know if there's a workflow to approve those external users? Because you listed that as an unknown, but I can tell you it's known. There's been exploits.
So a known way to approve those external users?
Yeah, before you're giving them project access. So a workflow that says this external user's been invited, approve them before they get access to something else.
I'm not sure about that because so what typically happens is once you invite the user, it sends them an email, and as long as they accept that, they're added to it. But I might have to take a look at like documentation, probably ways by which Google Cloud can add some restrictions around that, but I'm not fully sure about that.
Yeah, I have a question. Great talk, by the way.
Thank you.
Really, really great talk. I just wanted to ask, have you built any detection rules for any services in GCP that were incredibly complex? And if you do, what service was that?
That's a great question. Well, I don't think there's any particular one any particular service that was incredibly complex. I think it was like approaching detections for specific activities within Google Cloud. That was that was a bit complicated. It was particularly for detecting a tool called Gsploit. Yeah, Gsploit. And that took me a little effort and time to figure out how to do detections for that. Yeah.
Other questions for Day?
Yeah, great talk, Day. So
Thank
one
you.
question that I have is the attack path that you covered. Does it only include like the Google audit or audit logs, or does it also include like other audit log types? Because your detection is as good as where you can see and where you can monitor, right?
Yeah.
So does this attack path needs to have like additional logs enabled?
Yeah, so I should have actually added that context to this. So the attack path requires Google audit logs, Google admin logs. I believe those are the two main login, like the two main telemetry we'd want to have in order to detect all of these things. You're welcome.
Any other questions? All right, well, thank you so much, Day.
Thank you very much.
So next up will be lunch, and in between time, please go visit our sponsors. Thank you.